Good afternoon, ladies and gentlemen, here in New York City, 12th Cloud Expo. Welcome to the Lunchtime Keynote. Akamai are the ones behind this idea, and let's admit, it is a good one. So we're disproving the first myth of cloud computing. There is such a thing as a free lunch. Remember that, remember to tweet it. But much more importantly, remember to thank in advance Akamai's VP, Neil Cohen, who's going to take us through, as we munch, strategies for application delivery in this incredible cloud era. Neil, please, take it away, sir. 30 glorious minutes.
All right. Good afternoon, everyone. How are you? All right, welcome. Got an exciting presentation, as Jeremy likes to say. We're going to give you some content while you eat some content, but do appreciate the time today. My topic is strategies for application delivery in the cloud era, and maybe a visual to help you understand what I mean by that. I've been with Akamai for 7.5 years, and it's been really fun watching the way the internet has shaped and developed over time. And something is changing. You can look it, you can feel it, you see what's going on. True story, there's actually a payphone down the row at the Javits Center that looks really lonely, old, with instructions on how to use it. People don't use that stuff anymore. And I guarantee somebody during my presentation will pick up their phones, they'll take some pictures of my slides, they'll send it back to work, they'll tweet about it, and by the time I get off the stage, my PR team will be up here telling me about what happened during the presentation today. So good things only, please. But the hyper-connected world is changing everything in your work life and your home life with the proliferation of internet use, devices, and really when I fly around the world and I talk to customers, whether it's about cloud or otherwise, and I talk to them about what they're trying to do in enterprise IT, this is it. This is what they're trying to figure out, because this has a huge impact on the productivity of their workforce, as well as the opportunity that exists for their customers. So it's being able to take this hyper-connected world and where it's going, whether it's wearable computing, connected refrigerators, connected cars, that's where the world is moving. And as enterprise architects, we have to figure out how to take advantage of this new world that we live in. So we like to start with numbers to help you think about this opportunity and what you're going to have to do when you go back to your day jobs to take advantage of it. I think the first piece is the number of connected devices worldwide. So sometimes before you can go forward, you've got to look back a little bit. So this is just 5 years. And if you look here, just 5 years ago, there were about 2 billion connected, 1.3 billion global internet users. And that's doubled in just the last 5 years. Now, if you look at the number of connected devices, even though the number of users have doubled, there have been about a 4x increase in the number of devices, from 2 billion to 8 billion. And not only are there more users and more devices, but more dollars and more business processes are moving online. So if you use something like e-commerce as a proxy, you can see here that roughly a 3.5 times increase in e-commerce spend in the US on the web. And traffic is exploding. All right, so with more devices, more internet users, more dollars, more traffic. So you can see in just the last 5 years, we've moved to monthly traffic of global IP from about 6 exabytes a month, about 7 to 8 times as much at 43 exabytes a month. So a lot of growth. Now the bad part is with all these opportunities, the attackers are getting a lot more sophisticated and smarter and powerful in what they're trying to do bad things as you move more and more stuff to the cloud and to the internet. So in just the last 5 years, we've seen attack sizes grow from what used to be really big, about a gig, to now really pretty small, because the average attack size we see ranges around 10 gigs a second. So the question is, if that's 5 years back, what kind of things do you have to think about 5 years ahead to be able to take advantage of this opportunity in the hyper-connected world? So some forecasts, some ideas here. I think it's very fair to say the number of Usernet internet on the internet will double again, just like it did the first 5 years or the last 5 years. So there'll be more than 4 billion people connected to the internet. Probably see another 4x increase in the number of connected devices, so 32 billion connected devices that you can reach. About $2 trillion in e-commerce spend, right? So another triple. 120 exabytes of global IP traffic every month. And you're going to have to start thinking about not even 10 gigs of attack traffic, but how do you defend against, say, 100 gigs per second for a typical attack size? So with all of this growth comes what we think is a very difficult problem to solve, but is fundamental to everybody's business if they want to think about how to reach this connected users in this new cloud era. And this is a slide that you'll probably see a lot at Cloud Expo and otherwise. This is the kind of the 101 version of the slide, which is, hey, you know, you've got these cloud data centers, and you've got people who use the cloud, and then you've got this thing in the middle that they usually put either cloud or internet or something, and it just works that way. Now, those of you who are familiar with the way the internet works, that's not the way it works. The way we draw it usually looks like something like this. And a lot of people think about cloud. When they're talking about cloud, they're thinking about the data centers, right? So the first thing that's happening is that data centers are starting to move everywhere. In an enterprise IT shop, you've got your stuff in your private data centers, public data centers. You're trying to invent hybrid cloud environments where you're moving applications and workloads from one data center to another one, and you want to do that as seamlessly as possible. So the first problem is that the data centers are moving everywhere, whereas in the past, it used to be in a small number of locations. Okay, now the second problem is those data centers have to hook up to networks, right? And those networks, when you access over clouds, are very different than your private networks that sit inside of your firewall, right? Because they run on protocols that were invented decades ago. They were designed to work on the LAN and not the WAN. They don't give you an SLA, right? Nobody's going to say, hey, here's a service level agreement for getting content from somebody out in Europe back to your data center in New York City, for example. So the data centers are complicated. The networks that connect to them are complicated. And it's fueled by this connected device type at the end, right? So now you've got that data center problem, the network problem, and you also have a device problem. So back to the old days meaning just say 5, 10 years ago, most people were connecting on a desktop device, plugged into something like an Ethernet cable or a good broadband connection, and accessing their content through a certain type of web browser. And that's completely changed. Right? Now the devices that people are trying to connect to still include those desktop devices, your laptops, your tablets, your smartphones, different form factors, connecting to different networks, different speeds, different quality, different software running on those devices, because the browsers, the streaming software, the operating systems are all different. Right? It's gotten more fragmented instead of less. And the result is that whether you're trying to connect for a consumer website, a consumer media site, a business application, even security, this is becoming a really, really big problem that customers are trying to figure out. In order for me to be able to connect my users to my cloud data centers, there's all this complexity I have to deal with that I don't know how to cope with and can't solve on my own because it's outside of the data center. So, how do we do that? And there's a whole bunch of things that I could talk for days, and that's a different discussion at the booth if people want to talk in more detail. But I picked 3 areas that I think are impacting all of you in terms of the way you should start thinking about developing new strategies for getting applications delivered from data centers to devices with this new paradigm we live in with cloud, intersected by mobility and security. So I want to talk a little bit about cloud and make sure everybody understands what happens when you move infrastructure out to the cloud in terms of the end user experience. I want to talk about mobility because I see some of the cameras already picking them up and taking pictures. But mobility's changed the game, and these are different opportunities, but different problems that people have to think about with application delivery to be able to deal with the new complexities with mobile. And then finally, security, right? Security is top of mind. And I'm going to talk about the notion of using the cloud to protect the cloud as one of the ways to scale up security in the world we're starting to move towards. So let's talk a little bit about cloud. The first piece has to do with challenges with cloud performance. And the best way I like to describe this one is the notion of nobody's local. Right? When you take an application and you move it out to the cloud, really what you've done is you've just taken it from your own data center and now it's hosted out in a different data center. Right? So the question is, what does that do to the end user performance? Right? It does something bad. Because what you've done is you've taken an application that used to reside locally, close to the user, and you've pushed it far away. Right? Depending on where that cloud data center lives, it could be in the same country, it could be in a different country, it can be in the same coast, but regardless of what you're doing, you're taking the server and you're moving it further away from the user. Now, there's something you can do about that because the performance gets pretty bad, and I'll show you some examples, but most people don't really understand how to solve that problem because, to my point beforehand, it's something that seems like it's out of their control. It's outside of the data center. And the story usually goes something like this, right, is, well, my cloud data center or your own private data center, I bought a really, really good pipe. Right? I've got bandwidth, it's big enough, and it takes me, say, 0.2 of a second to get my content out of the data center. And then the story sort of goes like that and says, well, hopefully I got a good last mile connection because I'm connected to broadband, fiber, or a really good wireless connection. And let's just say that that takes about 2 seconds, 0.2 of a second. The problem has to do, again, with this cloud in the middle and being able to get stuff in what we call that middle mile, not the first mile or not the last mile. So if you do some math and you take a typical website and you just say that it takes 31 trips to build a web page over a certain amount of distance, you do the math and you say, hey, 100 milliseconds times a certain number of round trips, it's a lot of time. So very quickly, your bottleneck has to do with something that's outside of your data center that you can't control. So the way you do that is you can throw more money into bandwidth and more money into boxes inside of the data center, but that's not going to do anything because the bottleneck is outside. And the way you solve that is by using protocol optimizations to optimize the cloud. Right? So as I mentioned beforehand, there are protocols that are designed to run on the LAN, but not well on the WAN. And there's things you can do through services and leveraging cloud optimization services to be able to address those protocol inefficiencies so that you don't get that degradation as people get further away from that data center. So in a hypothetical example here, there's lots of different things you can do to reduce the inefficiencies of the page, the amount of time it takes to render that content, and taking something from an example of, say, 8 seconds and cut it down to 1 second. So let me show you a real example. Right, here's an example of a 4-step transaction on a SaaS application built on Amazon EC2 infrastructure. And again, this is the kind of thing you have to think about before you deploy and develop applications and roll them out on the internet. And you can see here, it took about 8 seconds to render that transaction in North America. And then somebody in Asia took about 59 seconds to optimize that transaction as well, just because of the fact that they took something from their own data center and they moved it out to the cloud. Right? Just because you move it to the cloud doesn't mean that it's going to perform well. Now, if you deploy some of those protocol optimization services that I mentioned beforehand, is what you can see here is this is what happens once you activate the optimization services. And you can see here that you cut the response time using the Asia case being the worst case example. You were able to take a response time of 59 seconds to run that transaction down to something acceptable to, say, 15 seconds. So cloud optimization makes a really big difference in terms of the adoption of your cloud-based services. Now, as you move to this cloud world, the other piece that people are asking is, how do you do that? Right? How can you do that so quickly? What people expect is when you go and you stand up applications on cloud infrastructure, they expect you to be able to move the optimizations as quickly as possible. Right? So that's really hard to do with the conventional way of thinking, which is I've bought boxes or I have virtual software and I'm going to take that virtual software and I'm going to go deploy it on cloud platforms. I'm going to manage it. and I'm gonna love it, and I'm gonna care for it. What they want to do is they want to be able to optimize on any cloud platform instantly. And the beauty of cloud optimization through a cloud approach is being able to do that with something as simple as a DNS redirect. And what you're seeing here is another example of an application built on Amazon infrastructure where you can see it took about 10 seconds to render a page. The optimizations were turned on instantly and cut that speed down to about 1 second. And on the time axis, it took about 20 seconds to deploy an application optimization template and then move it and propagate it on the network so that global users could get that good response time. That's the way the business really expects optimizations to work, in a simple way that allow you to take the goodness of accelerating and being able to apply it to your cloud initiatives instantly. Now, the second thing that you're hearing a lot about is not just the performance and the issues with adoption of cloud service because the experience isn't good. The other thing has to do with cloud outages, right? There's a headline every couple of weeks with regards to what's happening. So one of the adoption issues people have is, well, you know, I want to move stuff to the cloud, but how do I do that? How do I ensure it's high availability? And I think the good news is that the market is getting a lot more savvy about it. But to illustrate the point is, you know, one of the problems with cloud performance is that, again, it's just a data center or a handful of data centers. You have that same problem. Just like your data center, somebody else's data center can go down. And what that means is decreased availability. So if that server goes down, now you need to be able to respond in a timely way to make sure that your business doesn't go down. So there's a lot of different ways to do this. But one of the ways is what's called cloud balancing. Whether that's designing for multiple availability zones within a single cloud provider, and as the market gets more sophisticated, being able to balance across multiple cloud providers to get the different efficiencies and availability with different providers. But what people want to be able to do is continuously look at cloud provider availability with real actionable data. And if something goes bad above a certain threshold, take the data and take the optimizations and move it to another cloud data center or another cloud platform. And this is an example of using the same type of optimization services that make it faster, also to build for high availability cloud architectures using multiple availability zones as well as multiple cloud providers. A lot of times people make the mistake of actually building their load balancing functions on the cloud platform. That could go down. And if the cloud platform goes down, it kind of defeats the purpose of having your load balancing function on that actual platform because it can't make the decision. All right, so just trying to help you start to think about cloud, some of the challenges with adoption, some of the challenges with designing for high availability. The second piece has to do with mobile. And this makes a lot of the problems even worse. This is an interesting stat. I know this one's kind of consumer focused, but it illustrates the point whether you're dealing with mobile in the workplace or mobile for your customers. 50% of mobile users want the ability to purchase or place an order. Okay, so they're expecting some sort of functionality on their site. You can see 61% are expecting some information about your products. 74% want to know how to drive there and what hours you're open. But this is the one that drops me, right, is 81% expect their mobile sites to load in 5 seconds or less. And that's worth repeating because what it's saying is that more people care about the mobile web being quick than even something as fundamental as getting information or where the store is actually located. Because they've had the expectations of the experience they already have gotten for the last decade on a desktop site. So this is a good example, right? The first one here is I use Commerce because Commerce is typically bleeding edge web design, right? They're the ones who go and set the standard in terms of how fast things should go because it typically correlates with something like bounce rates and conversion rates on the site. And if you look at the 30 desktop sites, on average it takes 2 seconds to load. If you take those same 30 e-commerce sites and you look at it, they take 9 seconds to load. Okay? And to put that in comparison, the desktop sites didn't behave that way since 2001. So we're about 12 years behind on mobile response times as we are at desktop response times. And the expectations are, I want it today because that's what I'm accustomed to. Right? So this is the new challenge that everybody's got to think about as they start figuring out how to design mobile, mobile first, responsive web design, mobile apps, mobile web, all the different mobile initiatives. They don't get adopted if you can't solve this fundamental problem of how do they perform. So you got to change the way you're thinking about mobile. And at Akamai, we use the term situational. There are certain optimizations, like I talked about beforehand in the cloud example, that essentially are one size fits all. Right? There are certain things that the network is bad, and therefore you need to optimize the network protocols, and you get a certain level of optimization. The question is, what optimizations can you do above and beyond that that now start to get you even better response times for mobile than the other optimizations will do on their own? And by situational, there are different optimizations that you're going to have to start thinking about and doing and optimizing for depending on what device it is, because they render differently. Which browser? Different browsers have different sets of capabilities and process pages differently. Which version of the browser? What network type is it on? Is it on a 3G network, an LTE network? And at that given time, is that network in a good state, or is it oversubscribed and in a bad state? What is the latency? Are you connecting to an IPv4 or an IPv6 connection? Where is that user located? Do you want to change the content based on their longitude, latitude? Is that person logged in? All these different decisions need to be made on the fly for you to capture the mobile opportunity and optimize the experience for that user at that given time on the actual device and location they're at. And that's a hard problem to solve. So I'm going to help you think a little bit about some of the technologies at a very high level that are available to you. And I think the first one that I already talked about when I used that example of cloud adoption is what's known as dynamic site acceleration. At a very high level, really what you're doing is you're taking the network out of the way. You're optimizing the protocols that make internet use and cloud adoption suffer as people get further away from the data center. And for those of you who are familiar with performance waterfalls, what you're doing is you're making that whole waterfall render more quickly. Right? So a waterfall that took 4 seconds to render, in this example you can see it takes 2 seconds because every single piece of the waterfall loads more quickly. Now, the next frontier for mobile is applying situational performance optimizations that allow you to create a waterfall with fewer steps. And that technology, there's a whole bunch of things, but one of the areas is known as front-end optimization, which allow you to start optimizing the inefficiencies of the web code. And you can see the example here is what we've done is not only does the waterfall render more quickly, but you've shrunk the waterfall in terms of the number of steps that have to get rendered on the browser. And if you put those two technologies together, you now have something that's got a very powerful impact for the mobile user experience. Here's another example of what we call situational performance optimization. Images are a big problem for both business use and consumer use. And depending on the network conditions, some pages and content will choke based on the fact that you're trying to shove a whole bunch of high-res images to the device when the device can't process it because of the type of connection they're on at that given time. So you're going to have to make real-time decisions to be able to figure out what is the network condition, what is that image, and what kind of compression rates are you going to apply to that image real-time for that specific user adapted on that specific device. Right? So you need this evolving type of optimizations that more and more stuff depending on the situation versus one size fits all in order to really get mobile to start behaving the way that the desktop sites behave today. So this is a lot harder, but it has to do with the fact that the devices are diverse, the software, the browsers, and the networks all vary. So the net this is really what you want to try to do for your customers and your employees. It depends on your application and what the business impact could be, but this is an example of what the performance histogram would look like for something like dynamic site acceleration or taking that network inefficiency out of the way. And you can see here for the mobile users, you're getting a response time that ranges anywhere from about 1 second for 1% of the users, all the way up to more than 15 seconds for about 10% of the users, and everything in between. And you can see the peak there somewhere around 4 to 5 seconds. By layering on these situational performance optimizations on top of network optimizations, you can do a lot better. Right? And you can see here what you're now seeing is the aggregate benefit of the two combined. And you've pulled most of that histogram way below that 5-second or less threshold that I mentioned beforehand that the mobile users expect today now. And that's going to continue to move down. But these are the types of technologies that people are starting to architect and design for in order to go mobile first. Okay, so the last one is we talked a little bit about cloud adoption, the problems with moving servers away from your users. We talked about more of the problem getting worse with mobile users. Now the last one has to do with security. And security has to do with your own private clouds, as well as you moving and your comfort of moving stuff out to public clouds. But I mentioned that I'm going to talk a little bit about the notion of using the cloud to try to help protect the cloud. Security is a really big problem. I'll show you some data of what we're seeing on our platform, but 74% of companies have experienced cyber attacks in just a year. Of those 74%, 31% of them are taking down some sort of service disruption, and it's costing you a lot of money. So there's a lot of stats and surveys, but on average, the average cost of a data breach is about $8 million, and they can cost upward to $1 billion. And this is becoming a lot more prevalent. So here's a view into our platform. We're under attack all of the time. Our customers are under attack often as well. And you can see that rise in the number of customers we've seen attacked on our platform just over the last 4 years. So we went from 14 attacks in 2009 to 768 attacks in 2012. But as I mentioned beforehand, what you're going to have to think about and how to protect from. Today, the average attack we're seeing on our platform is about 10 gigs a second. I mentioned beforehand it's not unreasonable 5 years from now to have to think about protecting from 100 gigs a second. And we've got evidence of that because we have seen attacks today that have gone above 100 gigs a second. Right? So those attacks are actually happening now, but they're more of the exception than the norm. 5 years from now, that's exactly what everybody's going to have to contend with. And they're massively distributed. They're not coming from one location or a small number of locations. They're coming from a lot of sources in the way that they've decentralized the bots to be able to attack your infrastructure. Now, what makes this a really hard problem to solve is not just the size, but what I've been talking about so far has to do with that blue part of the pie, which is denial of service attacks, which is only 23% of the problem. Right? So you have to contend with having to deal with 10 to 100 gig size attacks in the future 23% of the time. The other 77% of the time, you've got to worry about more application layer attacks, things like SQL injections, cross-site scripting attacks, other things people are trying to do to sneak their way into the application. And that, too, requires a tremendous amount of processing because as your traffic grows, you've got to run rules hundreds of times on every single request that tries to slip its way into your web properties. And that's a very hard problem to solve. So since it's a hard problem to solve, another headline slide is you've read the headlines where these current normal approaches to solving these attacks don't work, or they don't work very well. So people have spent a lot of money trying to architect for secure infrastructure, whether it's built on cloud or their own data centers. But they've got a lot more to do as it relates to dealing with the increased size, sophistication, and scale of these attacks. The reason it's a hard problem to solve has to do with this slide here is the attacks are coming from lots of different sources and lots of different locations. And it's really, really hard for you to try to figure out how to build out security capabilities in a small number of locations. Because you can imagine how many boxes you got to rack, stack, buy bandwidth for, or move virtual software to put on cloud platforms to contend with 1 gig, 10 gig, 100 gigs, all the application layer attacks. And that once the attack centralizes and coordinates into a small number of locations, it's really hard to build that infrastructure to be able to defend, because once it's congregated, you've kind of lost already. Right? So to my point about using the cloud to defend the cloud is the best way to deal with distributed attacks is to distribute the security processing. And that's where the cloud comes into play. And an example of that would be using the same services that are used to optimize the performance and the availability of the cloud, but also to protect the cloud. And here's an example of those same types of servers that are distributed out in the cloud for people to rent and lease the optimization services that can also run things like DDoS mitigation capabilities and layer 7 firewalls in a distributed manner that scales on demand. So as the attack starts to congregate, those servers that are distributed work the same way as regular servers. They still run out of capacity at a certain point, but that's fine because you've distributed the attack. It allows you to leverage lots of different servers, and if one of them gets flooded and runs out of capacity, well, then you just keep adding more and more and more as the attack size grows. And that's exactly what I'm illustrating here with a cloud defense. So let me show you a couple of examples just to help you think about the types of problems you're going to have to think about over the next couple of years. This is going to become pretty normal for all of you. Today it's a big event. A couple of years from now, it's not going to seem very big at all. And this is what the Summer Olympics looked like in 2012 for defending the websites just last year. And what you're seeing here is an attack that happened a couple of hours before the opening ceremony. And it was pretty nasty. You can see 23 types of requests were denied, right? Bad robots, injection attacks, cross-site scripts, injection-style attacks. It had to fire about 25 million rules during that attack. It was about 40 times the normal traffic. But the stat that kind of drops everybody into a quiet is we had to filter 132 billion rules and requests for 2 weeks to be able to protect this kind of scale and this kind of website. And that's the kind of stuff you have to think about, is what do you have to do at scale for all your web properties for every single request, whether it's denial of service, application layer attack. And you've got to start thinking and architecting for these types of challenges, which is as things get bigger, as the attacks get worse, how do you leverage the cloud to get scale and robustness out of your security perimeter that you can't build in hardware on your own in one or a small number of locations? The next example I want to talk about is what's going on with Operation Ababil. So I don't know how many of you are familiar with this. But you can see some of the pastebin chat boards here that I've highlighted. Essentially, it's a lot of the attacks you've been seeing on the banks over the last 4 or 5 months here in the States. And again, this is an illustration of the types of scale and challenges that all of you are going to have to think about as we live in this new world of hyperconnectivity. But you can see here is I wanted to give you a little visibility in what these attacks actually look like, and just how smart they're getting in terms of how they're changing their tactics. So what was illustrated in the chat there is there was a phase 2 and a phase 3. Actually, there's a phase 1 as well, but that one wasn't as illustrative for the slides here. But this is what a phase 2 attack looked like on a major US bank. It was 10,000 times the normal traffic. It was 23 gigs a second. But what was most interesting about this one is that it attacked the DNS infrastructure, right? So those dusty old DNS servers in your closet somewhere, you can spend lots of money on web security and different things to deal from DDoS mitigation and application, web app firewalling, intrusion detection. But if you forgot about DNS, you're down, right? So this was a very different type of attack massive at scale that had these companies not have thought about how do I scale up my DNS infrastructure, those companies would go down. Now, phase 3 looked totally different, right? So as I showed you in the paste bin, is that, hey, here's phase 2. They go back and they say, well, what can we do for phase 3? And phase 3 looked something like this, where they hit banks with peak attack traffic of about 4 million requests a minute. That's the kind of stuff you're going to have to start thinking about. And it came from about 1,700 different sources. And those IP addresses kept rotating over time so that if you try to shut them down, there'd be new ones. And that's where something that we call just rate controls becomes a very powerful mechanism when done in the cloud, being able to look at IP addresses and set certain criteria and essentially push back on the bad guys if they exceed a certain threshold. And you can either serve them an error page, you can trick them and serve them a legitimate page so they think, or serve them a down page even if the site's still up so they think they took it down. You can serve them a CAPTCHA. You can throw them a big file so they take a while to come back. There's a lot of different actions you can take. But this is the general idea that the attackers are a lot smarter. They're looking at your infrastructure and they're trying to figure out what the right things to do are as they sneak their way in. So I talked a lot about really 3 different things, and hopefully I gave you some different perspective on most of the customers that I'm speaking about right now. They realize something is different. There's an opportunity right now to redesign their architecture, to harness the opportunity that comes for hyperconnectivity with their employees, with their customers. But these are the big things that are on their mind, and it's kind of like the perfect storm at the same time because they're all fueling that entire business, right? It's how do I get better agility, cost efficiency, and alignment with the business by leveraging cloud without fearing adoption. What am I doing about this mobile thing because it's that much worse, but it's that important for everybody. And then security is becoming a bigger and bigger risk as more people move stuff to cloud as well as the internet in general. And then ultimately, as you think about rolling out cloud services, you don't want it to be a dud, right? As you don't want people to come back and yell at you and say, this was not a good experience for me. I'm not going to use it because it doesn't perform well. It's not highly available. And then we believe this is one of the key inhibitors that as people start to design and architect with these types of optimization services, the adoption will follow and people will be more and more comfortable with people leveraging cloud services within the enterprise. And then the last piece is, just in terms of application delivery, I'm asking you to think a little differently when I show you the data at the beginning in terms of what the attack sizes are going to look like, how many internet users you got to connect to, how much traffic you're probably going to have to deal with versus today. You got to think differently than the way we think about boxes and data centers and virtual software. There's different ways that harness the cloud to be able to solve these new application delivery challenges in the cloud era. So that said, I appreciate everybody's time over lunch today. I encourage you to visit the booth number 418, where we've got a couple of cool things to demonstrate. The first one is if you want to see the internet being delivered real time, we've got a visualization there that shows today we're doing about 8 terabits a second. But if you want to see how about a quarter of the internet's working right now real time, we can run a demo and show you how that content looks. We've got a demo showing you how to balance across data centers in a multi-cloud provider environment, top of mind for a lot of you. And then the last one is the state of security. So if you want to see more about the intelligence we see on our platform, where the attacks are coming from, what types of attacks, you can drill down by region and just kind of get an overall view of the internet health, not just for performance, but the attacks. Please drop by our booth. So thank you again, and I look forward to meeting all of you.
Thank you so much, Neil. Now,